Day 146, Kirchoff's laws. Homework example number 1 solved. We have a single loop here, and I've redrawn it over here on the left, and I've simplified the diagram a little bit because we have 3 resistors in series, so they just add up numerically. 2.5 plus 0.4 plus 0.2 gives you a total of 3.1 ohms of resistance. And we have a single loop, and I've labeled it. You really wouldn't have to label it even. There's a single loop here. And I've designated the current as I. You don't need to call it I sub 1 or I sub 2 because it's a single loop current. So I take that loop, doesn't matter where you start, but loop A, B, C, D, A, that's the direction I'm going in. And there's 3 elements generically. V sub 1 plus V sub 2 plus V sub 3 equals 0. So there's my loop condition. And if I go in the arrow starting from point A, I hit the battery conventionally. The 18-volt battery is a positive 18 minus the voltage drop for the resistor, which I don't know yet, minus 4. So that's unconventional. I'm going backwards through the battery. I'm going from C to D. That's why the battery is negative, irregardless of the arrow, the blue arrow. I'm doing a loop in this direction, so I'm going into the positive, down the negative. So that battery is pointing up. Unconventional, then I have a negative 4 volts for that battery. So therefore, the voltage of the 3.1 ohm resistor, which I'm also calling generically V sub 2, is 14 volts. If I know its voltage, I use Ohm's law, V equals IR, to get the current in that 3.1 ohm resistor as 4.5 amps, but that's the current in the entire circuit because it's one loop, so therefore I have part A done, 4.5 amps. And then part B follows. The power used or transferred to heat or light by a resistor is best calculated by I squared R. You could do VI as well, but we have the current as 4.5 amps squared times the resistance gives you 51 watts, joules per second, of power output by that battery, or by the light bulb or resistor. And then they're asking for the energy stored in the 4-volt battery. Basically, you're charging that battery. If we're assuming all the energy is stored during that time, there's no losses. The power input or output by a battery, in this case, it's energy put in, power put in. The other battery is putting out energy or power. But for a battery, do P equals VI. The voltage of that battery is 4. Its current's 4.5, so it's 18 watts, which is 18 joules per second times 7,200 seconds in 2 hours. I've converted or found out how many seconds in 2 hours, 120 minutes times 60 seconds per minute. And I multiply that to it, I get 130,000 joules of energy, 130 megajoules, 130 kilojoules of energy stored in that battery.